Hi everyone, for this question number 3, we are given two functions here, fx and gx. Both of them are quadratic. So the difference here is this quadratic is not the whole graph we are using. We have special condition here where the first one is they take more than equals 0. For gx here, they only take x less than k. So we observe the quadratic here for fx. It is x equals to 0 and x equals to 2. So function of this graph it is 0 and 2. This is our graph and it taking more than 0, which means that this function only happen start from domain 0 to infinity, only one side only. Then if we observe on gx, for ax squared plus 2, ax squared plus 2 means quadratic plus 2 without bx means your quadratic will be in the middle. And when x equals to 0, here is the value 2 here. This a is your gradient of your graph, whether it's steeper or become flatter or flattened. And the domain it take here is x less than k, so one part only. So your y-axis, x-axis. This is the x-axis, this is y-axis. Let's say for the first questions, they say for k equals to 1. When k equals to 1, it will be at here. K equals to 1. So here will be k equals to 1. When k equals to 1, determine G inverse exists or not and state your reason clearly. So our answer will be for k equals to 1, you can see your graph here, you are graphing here symmetrically at 0, but when you cut here half, so you still have horizontal line cutting 2 points. So for k equals to 1, your quadratic is your G inverse does not exist because our function is not one-to-one. And state your reason clearly so we can draw out the graph. Y, x. So this is the quadratic. When x equals to 1, less than that. So the domain, if the domain here is less than 1, we will have the graph like this. So very obvious. Your graph, we want to test, is it one-to-one? It will cut 2 points. Our function is not one-to-one. So when our function is not one-to-one, our G inverse does not exist here. So that will be our part A. So for part B it changed. It changed to k equals to 0. So k equals to 0 means definitely at the middle here. For k equals to 0, now our graph will be less than 0. So only here, 2. So this is our gx. Alright, this is our gx, ax squared plus 2, and then less than 0. So k equals to 0. X-axis, y-axis. So when you have condition of the function, when your function getting condition, you have to analyze it from the graph, then you will be better vision on that. For the first part, find the G inverse. So now we can find the G inverse because the graph here is one-to-one function. So G inverse equals to X using composite method. So substitute G inverse to our function here. Substitute X here. So A G inverse square plus 2 equals to X. We find out our X here. We find out our G inverse here. Move it one by one to the right hand side. And when we square it, we have positive, negative square root. Quadratic, move it to the right, you have two answers. And then since our condition is taking left hand side, since our x is less than 0, alright, the x less than 0, which means that we only taking the negative part. Therefore, our G inverse is negative square root x minus 2 over a. And the question asks us, after you find the G inverse in terms of A and state its domain. So domain of G inverse, we referring to the graph here function. Domain of the function now is 0 to less than 0, means negative infinity to 0. Range of the function now, you can see the minimum part is 2 up to infinity, and this point is not included. Alright, this point domain stated here x less than k, x less than 0 is not included. So therefore, this point 2 is not included. So when we answer the domain for G inverse, we referring it to the range of the function, which is 2 to infinity. So that is part B number 1. Then we continue to part B number 2, find fgx in terms of A and its range. So sorry to say that composite function with its range, this part is not in your syllabus already. Alright, so this is domain and range involve composite function. It will be another concept where you didn't learn it. It is not in your syllabus. You only learn domain and range for the function and inverse function. So for this part, we just calculate f. We only find for composite function fgx in terms of A only. So for part number 2, we find fgx. So substitute the gx here. Gx here is ax squared plus 2. Then we substitute into fx. Fx here is x times x minus 1. So x times x minus 2. Alright, substitute the x here, x times x minus 2 with this ax squared plus 2. So we simplify, this is ax squared plus 2 times ax squared. So continue, it will be a squared x to the power of 4 plus 2ax squared. So that's all for this question. So now we see how to score these questions. From the first part, 2 marks, determine whether the G inverse exists or not. So our answer, just G inverse not exist, and then give out your reason clearly because it is not one-to-one function. So this is your answer. So when we drawing graph here, bear in mind to label horizontal line dash 2 in the section point. So So this is our GX origin. Okay, make sure you clear about it. And this is not included, so empty circle. Then second B1 here, finding G inverse. Firstly, composite function, concept of composite function, and then you simplify to the answer here. This is your answer. Simplify. Okay, get it, simplify here. Get it to G inverse, got two answer, get to the answer, and then the domain of this G inverse, one answer, then do your composite and simplify to the last one. So we adjust the mark here, so that's 7 mark. 1, 2, 3, 4, 5, 6. So 7 marks. Substitute your G inverse 1 mark. Alright, so we get here 1 mark, simplify. Get in your G inverse, got two answer. Got two answer, then only you take the negative part. So 1, 2, 3, 4, 5, 6, 7. 7 mark. Alright, so that's all for this question.